Good afternoon. I am Mr. Ish. Thank you for joining me for this video here. We are looking and focusing on ideal gases, but with regards to the ideal gas law, that's a primary focus. PV is equal to nRT. Remember, in all instances, this value n, your number of moles, can also be written as mass divided by molecular weight, or your molar mass, RT. Given that in mind, let's look at this question we have right over here. Gas X, we don't know what X is, but it fills a 2.5 liter flask at a pressure of 1430 torrs. Temperature of this specific experiment is minus 90 degrees Celsius. The weight of the flask before the gas was pushed in was 100 grams, but the weight of the flask after which the gas has been pushed in is 105 grams. We have to find the molar mass of this X. We know pressure over here is 1430 torr. You have to convert that into atmospheres, because with this equation you're looking at atmospheres, liters, moles, your universal gas constant, and Kelvin for the temperature. 1430 torr times 1 atmosphere is equal to 760 torr. That's your conversion, which is not hard. We don't even have to solve this out right here. We can put everything here into our final answer and then solve it then. What about our change in mass? The flask was 105 after the air was pumped in, but the weight of the flask is 100, so the difference is just 5 grams. That's the mass we've determined. The volume over here is 2.5 liters. It's in the correct units. We know our R value, gas constant, is 0.0821 liters atmospheres over moles Kelvin. So that's not too hard. And the temperature, minus 90 degrees, has to be in kelvins. You do 273 minus 90, and that'll give you your temperature in Kelvin. Remember, 0 degrees is 273, minus 90 will be 273 minus 90, and you get here 183 kelvins. Plug these values in, and you're solving for n. N, which is your mass or molecular weight, is equal to PV over RT. Our pressure is going to be 1430 divided by 760. Our volume is 2.5 liters. We have a gas constant 0.0821. We have over here temperature of 183. This is equal to your mass, which we've determined the mass is 5, or your molecular weight, which I'm calling X, or your molar mass X. We have to solve for that X, and it's not hard. Work here in the numerator. 1430 divided by 760, we have these many atmospheres. We'll multiply this by 2.5, the volume, divide this by 0.0821, your universal gas constant or ideal gas constant, divide that by 183 Kelvin. You save this value because you're going to do 5 divided by that saved value. 5 divided by that saved value, and I get a value 15.96. X over here is equal to 15.96 grams per mole, and this would be your molecular weight or your molar mass of that compound X. And your question would have been solved and your answer would be right. Let's close out this video with this question here. How many liters of oxygen gas are needed at STP, standard temperature and pressure, to form 12 grams of water? You know, this right here is the equation. H2 plus O2 gives you H2O. You have to balance it. When you balance it, this is what you get. The question is how many liters. We have to determine the volume of this at STP are needed to form 12 grams of water. Well, you're looking for this, but you have this 12 grams. 12 grams divided by the molecular weight of this water will give you exactly what you need here in terms of moles. So let's start with the moles of water. We have 12 grams of water times 1 mole of water is always equal to 18 grams in terms of the molar mass. Then we have here 1 mole of oxygen is available with regards to 2 moles of water. And you'll see how everything will cancel out. And then everything relevant will cancel out is what I mean. And then you have to think about everything here with STP, and you have to somehow convert a mole into a volume, for which you have that conversion factor. 22.4 liters. This is called your molar volume of a gas at STP. 22.4 liters of oxygen would be generated or would be occupied by 1 mole of that oxygen, and that will give you exactly what you want. The grams water will cancel out with this grams water, mole water with this mole water, mole oxygen with this mole oxygen. Everything which remains will be everything that you need for your final answer. You have 12 times 1 times 22.4 divided by 18 divided by 2. So you do 12 times 22.4 divided by 18 divided by 2, and your answer would be 7.5 liters, and that answer would be right. 7.5 liters. of oxygen at STP are needed to form 12 grams of water. Now, just for interest's sake, if someone were to ask you what's the volume of water generated, you can do this the long way, or you can do this the short way. The short way is just recognize that each mole of oxygen will generate 2 moles of water. In terms of their molar volumes, all you have to do is this multiplied by 2 and you get 15 liters of water will be generated from this reaction, 15 liters. And that's like the short, intuitive way. But if you were like second guessing or doubting yourself that if indeed this is good, you can do it the long way, and let's do it the long way. We had 7.5 liters of oxygen which are generated, and each 1 mole of oxygen in terms of STP in its molar volume has 22.4 liters of that oxygen in terms of the volume of that oxygen. Anyhow, we also have, based on this reaction, 2 moles of water which are generated for each 1 mole of oxygen which reacts. And we also know, based on the molar volume, that 22.4 liters of water in terms of its volume would be occupied by 1 mole of that water. And now look, exactly, you get the same thing. Liters of oxygen, 1 mole of oxygen, 1 mole of oxygen, moles of water, moles of water. The only thing which remains here is liters of water, which is good. All you got to do is recognize the fact that this conversion factor 22.4 cancels with that. All you're left with is 7.5 and 2. 7.5 times 2 will give you exactly what you had, 15 liters of water. So that is good, and our answer is right. In this reaction, you're looking at 7.5 liters of water combining by means of this. We're not even looking at this yet, but you could. 7.5 liters of oxygen are generating 15 liters of water, and everything checks out by means of this factor label method I've put for you. And the stoichiometry I've shown you in this question right here should be good. And thank you for watching. Have a good day.